5 important equations to remember while solving unsymmetrical fault analysis in power system. Equation 1, symmetrical component of current, which is represented like this: IA naught, IA plus, IA minus, that will be equal to the T inverse matrix, that is 1 by 3, 1, 1, 1, 1 A square, 1 A square A into IA, IB, IC. These are the phase current. IA naught, IA plus, IA minuses are the symmetrical component of current or the sequence current. IA naught is zero sequence current, IA plus is positive sequence current, and IA minus is negative sequence current. Equation 2, symmetrical component of voltage. Similar to current, here the expression will be VA naught, VA plus, VA minus, that will be equal to the T inverse matrix, that is 1 by 3 into this matrix, into the phase voltage VA, VB and VC. Equation 3, symmetrical component of voltage derived from the sequence network of generator. So the equation 3 is different from equation 2. So here it will be given like this, that is VA naught, VA plus, VA minus, symmetrical component of voltage, that will be equal to 0, EA 0. So here this matrix represent the generated EMF of a synchronous machine, and since the generated EMF is balanced in a three-phase generator, there is only positive sequence voltage present, that is EA. The zero sequence and negative sequence voltages are 0, and this matrix minus the Z matrix, impedance matrix, into the sequence current IA naught, IA plus into IA minus. So this is a complete representation of symmetrical component of voltage from the sequence network of generator, where this Z naught can be represented as ZS plus 3 into Zn, where ZS is your self impedance of a generator plus the 3 times the neutral impedance, and Z plus the positive sequence impedance is equal to the self impedance Zs, and Z minus is equal to the self impedance Zs. Now equation 4. Equation 4 represents the phase current. The phase current can be given like this: IA, IB, IC. These are the three phase current: IA, A phase, B phase and C phase, and that will be equal to the T matrix, the transformation matrix, into the sequence current IA naught, IA plus and IA minus. So phase current equal to transformation matrix into sequence current. In the similar way, we can form the equation 5, that is phase voltage VA, VB, VC, that will be equal to the T matrix into sequence voltage VA naught, VA plus and VA minus. So these are the 5 very important equations which we are using in the unsymmetrical fault analysis of the power system.